In this video, I'm going to solve an example based on the superposition theorem. So here in this video, find ammeter reading as well as Vx voltage at this point by using the superposition theorem. So we know that in superposition theorem, we're going to keep one source at a time, replace all other sources by using their internal resistance. So here I'm going to first go with the 3.6 volt source and replace the current source with open circuit. We know that current source internal resistance is infinite, and replace the voltage source with short circuit and find the ammeter reading and Vx. So here I found the current is nothing but this 1 kilo ohm and 5.1 kilo ohm. They both are in series. So 3.6 volt divided by 6.1 kilo ohm, the total current is 0.59 milliampere. And you can use the Vx must be, I use the current division rule, but at the same time you can use the I times 5.1 kilo ohm. That will give you same thing, 0.59 times 5.1. This is milliampere, that's kilo ohm. Milli-kilo get cancelled out, approximately 3 volt. Okay, that is the voltage. So here I'm going to call this as I prime and Vx prime because the current is because of only one source, and Vx prime and that's voltage because of only one source. The next one, this is step 1. In step 2, I'm going to use the second source. Okay, so here the voltage source is short circuited, another voltage source is short circuited. So I'm going to call this current as I double prime. I double prime, I can use the current division rule. Total current multiplied with, so these two resistors are in parallel, whatever this 3.2 milliampere, it is going to divide as I1 and I double prime. So I double prime equal to total current multiplied by opposite resistance over total resistance. This is the formula. It's just a simple current division rule. This current I end up with 0.524 milliampere. Okay, at the same time Vx double prime equal to, I can use the same formula, I double prime times 5.1 kilo ohm, or same as I times 1 kilo ohm will give you the same thing, which is 0.524 milli times 5.1 kilo, that equal to 2.675 volt. So Vx double prime is 2.675 volt and I double prime is 0.524 milliampere. Now that's a part, step 2. Now step 3, I'm going to keep the voltage source. So here current source must be open circuited. Here is my ammeter, 5.1 kilo, and here this is 7 volt. We did this in our lab today. So we did this lab in our class in the lab today, but numbers might vary. I will discuss that in a second. So here I triple prime equal to, so the current, this current is going to be flow from the voltage source. Let me take this as Ix. This Ix is going to flow in this direction, but at the same time I want the current I triple prime which is opposite to the Ix. Okay, so we'll end up with I triple prime equal to minus 7 over 6.1, or you can say Ix equal to 7 divided by these two resistors are in series, so 7 divided by 6 kilo ohm will end up with 1.147 milliampere. It's negative because it's in the opposite direction. Same way Vx must be Vx times the current passing through this 1 kilo ohm. This current is 1.147 milliampere. So Vx is higher potential. So Vx is Vx triple prime is a positive number. I end up with 1.147 volt. So the Vx prime is 3, double prime is 2.675, triple prime is 1.147. So the total voltage at that junction equal to 6.822 volt. And the total current is approximately 0. This is the final answer. Now I'm going to show you what we did in the lab. So when we did in the lab with only battery source, the voltage we end up with 2.64 volt. There it is 3 volt. That could be because this is the real experiment. There the battery voltage might be not 3.6 volt. Probably I have only 3 volt. That is the reason the rest of the voltage is 2.64. So based on the voltage I end up with 0.52 milliampere, but from the calculations it's 0.59 milliampere. It's almost same. Now the solar panel I end up with 1.8 volt and 0.34 milliampere. Here with the solar panel I end up with 2.675 volt and 0.524 milliampere. Solar panel is a current source. It supply current, constant current based on the sunlight available. So probably here this is a practical one, this is a theory. So there I took that as a 3.6 milliampere, but here this could be like light is not sufficient. That could be the reason it is supplying only 0.34 milliampere, and the voltage across it is 1.8. And totally, I mean, I agree with these numbers. It's based on purely with the sunlight available. So we used a bulb in the lab to get the light on the solar panel. The third one is a hand crank generator. I said it is 7 volt source. Here, so the voltage drop is 1.147 and the current passing through it is negative 1.147. So hand crank generator, you can see it's 1 volt and negative 1 milliampere, approximately close enough. And here also the difference might be because maybe I'm rotating it on a different speed, different variation. So theoretically the total voltage is 6.8. Practically I end up with 7 volt, very close, and the current is 0. Okay, so this is the experiment we did in the lab today. So based on that, our theory and the practical almost close enough. There are a few errors here and there, and as I mentioned, that could be because of the how fast you're rotating, and that could be maybe you're rotating one time in clockwise direction, the hand crank generator, and another time anti-clockwise direction. That makes big difference. And as well as the sunlight on the solar panel, sometimes you might be holding it very close, sometimes you're holding it a little bit far away, so sunlight is not sufficient. So this is based on the superposition theorem. I hope you understand better superposition theorem after the lab today. Thank you.